Good evening, and welcome. All right, good, excellent. Welcome to Kopernik Observatory. My name is Drew Desker. I'm the director here at Kopernik. And it's great to have you here this evening for our Friday night program. Also want to welcome those watching on the live stream. I always do this. Who's here for the first time or not since your fourth grade field trip? All right, a few of you, all right. Anybody here members? A couple? All right. Well, the people who can't raise their hand second here have a particularly valuable piece of information. Kopernik, we're a nonprofit, but a Kopernik membership gets you into Kopernik every Friday night and for any other special occasions we've got. But we belong to what's called the ASTC, Association of Science and Technology Centers. There's over 350 other science centers in the area, not in the area, in the world, quite frankly, that will honor our membership card. So if you like this kind of place, you might want to consider getting a Kopernik membership because it's pretty cost effective, and you can go to Roberson for free. You could go to the Museum of Science and Technology up in Syracuse, or the Discovery Center in Ithaca, the Franklin Institute down in Philly, or the Intrepid down in New York City. And very often, especially places like the Intrepid or Franklin Institute, if you were to take your family with you, you would pay more than the whole year's worth of a club of a membership to Kopernik. So might be something to consider. So Kopernik has actually been around for over 50 years. Last year, we actually celebrated our 50th anniversary. We officially opened our doors in 1974 as a public observatory. For a number of years, it was run by Roberson, but since 2007, it belongs to the Kopernik Society of Broome County, the people who originally built the observatory. In fact, actually, that brick wall just to my left, to your right, is the original building. And so now we're continuing our mission of outreach, not only as a public observatory, but just an informal STEM education facility. We are actually on Monday. We've got some school groups starting to come back up here, and so throughout the school year, school groups will come here. We will also go to the schools to provide sort of augmentation for their science and engineering curriculum. We have a very extensive summer camp program for kids that are between, or I guess, rising second graders up through high schoolers, and it's these are week-long day camps that we offer. Some of the programs we offer are sort of introductory, looking at the world, through the eyes of a scientist. Up through this past summer, we ran I ran a program called Return to the Edge of Space, where our students build a payload that goes on a weather balloon that flew up to over 100,000 feet, and we run cameras on it and science equipment on it, and once we get the packages back, if we get the packages back, this year was a little bit of a challenge. We got some of it back, but then the students evaluate what the cameras saw. We compare the flight data to what we expected it to be, and then try to come up with conclusions as to why it did what it did versus what we thought it was going to do. But one of my favorite things to do is these Friday night programs. It's an opportunity for us to really sort of learn and extend our knowledge of how the world, how the universe works. Not everything we talk about on a Friday night is, in fact, about astronomy. Tonight's program is, in fact, a great example of that. But again, you can also, if you go to our website, you can always keep on top of that, what's going on. So here was tonight's program is Solving the Mysteries of Easter Island. What I will point out is actually next Friday and Saturday is our annual Hocus Pocus Halloween extravaganza, where we have various activities, sort of, I want to say a haunted observatory, but sort of science related, and the treats for the kids, and you're invited to come dressed up. You need to have tickets for this, so if you go to our website, you can click down here and get tickets for it. And then actually, the following Friday is actually Halloween night. So we are going to do just a casual night of observing. So if you need to get away from the crowds, this would be a great place to come for that. But again, what's also nice about what we do here on our public programs is we live stream it all. So actually, back in 2020, when COVID hit, we had to stop having people come to our Friday night programs because you couldn't put people into a room, and we figured, okay, let's just wait a couple of weeks until this thing blows over, and didn't exactly work out that way for us. But we had all these people lined up to speak, and we thought, well, why not just have them zoom into our facility here? We'll just push it back out on our YouTube channel. We now have nearly 14,000 subscribers on our YouTube channel, and all of our programs, if you go to our YouTube channel, all of our programs are listed right here. So last week we had a talk on fall skies. Previous week was our Astrofest weekend. The week before that is powering the clean energy careers. We've had talks about what's causing butterfly decline. So not everything we talk about is always astronomy related. But one of the other things we do is whenever there is some kind of an astronomical event, like a lunar eclipse or a solar eclipse or a meteor shower or even an aurora, we will actually run an observing session. In fact, Jenny, who's actually driving our live stream this evening, was up here. There was a lunar eclipse back in March, which probably none of you saw because it started at 2 in the morning. But Jenny was here all night for that, and she put together this 1-minute time lapse. You see the penumbra the Earth's shadows start to cover up the moon. Now, eventually she'll change the exposure so that we can actually see that quote-unquote blood moon. Again, what's going on with the blood moon is you're seeing long wavelength light, the red light, refracting through our atmosphere and continuing on to illuminate the moon. It's not the end of the Earth, as often is attributed to that. And then once it comes out of the shadow, we're back to, again, she'll change the exposure again. And what's neat about, if you look out outside at night during a lunar eclipse, normally at a full moon, you only see the brightest stars. You never see the Milky Way. But once the eclipse goes into full eclipse, all of a sudden, boom, the Milky Way just pops right out. So anyway, so what's great about this is that you can go to our YouTube channel. You can even watch tonight's program later on, tomorrow. Very often, actually, people from around the world end up watching our programs. In fact, there's a woman in Adelaide, Australia, Lindsay, who is often on. For her, it's 10 o'clock in the morning. So she just finished breakfast and is putting breakfast dishes away and watching our live stream. So anyway, we're very fortunate to have Dr. Carl Lipo here to do a talk on what he does best in research at Binghamton University. We've had him here a few years ago, and we figured we'd have him come back and see what new you've discovered. So I'm going to switch this over to your presentation, and we'll go from there.
Everything working on the audio side? Great. Well, thanks for coming tonight. It's a beautiful night, so I can't wait to go outside and see some stars. So I'm Carl Lipo. I'm a professor of anthropology, an associate dean for research at Harper College. I've been working on Easter Island for about now 25 years. Sort of hard to believe that so much time has passed. And I've been really struck by the sort of amazing things that you can find there, these gigantic statues. So I want to share a little bit about the work I've done in terms of understanding these statues, Some of the more recent stuff we've done in terms of documenting the landscape there using drones and building 3D models and all kinds of cool stuff. And then there's a bit of a cliffhanger at the end where we're going to ask a question that we've started to do research. It's really interesting in terms of where this idea comes from that we don't quite have the answers yet, but we've gone out and done some work. And I'm going to share that with you. So hope you enjoy this. So Easter Island, or Rapa Nui, is located in a really remote part of the Earth. It's thousands of miles from other places of land. It's thousands of miles from South America. It's thousands of miles from Tahiti, the other nearest other land. And it's a tiny little island. So it's this teeny tiny island, all isolated by the Pacific Ocean, by thousands of miles of ocean. It's only about 10 miles by 7 miles, actually 15 miles by 10 miles across. It's a very small space, and it's isolated by no other island. So once you get to this island, this is it. Your entire life, your entire universe is here in this space. Where do we go here? It's here's a good example. It's a volcanic island. It's a volcanic island that was formed over about 1 million years ago, 1.2 million years ago. It sort of came together about a couple 100,000 years ago. And then the last eruption was maybe 10,000 years ago, some of the estimates. It's built of 3 volcanoes, Ranokau, Teravaca, and Poike. Each of them were volcanoes that erupted separately and ultimately merged together to create this island. You can see lots of other vents there, all different vents of volcanoes where ash and lava poured out at one point. And it's not active anymore. It's an extinct volcano, very stable. So if you go there, you don't have to worry about eruptions of any sort. People got to the island at about, we'll talk about that time. The Polynesians got to the island on sailing canoes. I mean, it's an amazing thing that people were able to find this tiny little speck of land amongst the gigantic empty ocean of the Pacific. They had large sailing canoes. The Polynesians were remarkable sailors and were able to systematically go to all the islands across the East Polynesia, Hawaii, New Zealand, the Austral Islands, Tahiti, and find these islands and colonize them. And Rapa Nui was one of the colonized islands by the Polynesians who sailed out there. The sequence of sort of colonization of Rapa Nui kind of begins in Eastern, well, it does begin in East Asia, as people sort of 5,000 years ago spread out of sort of the northern Philippines and Taiwan across sort of near Oceania, it passed New Guinea, ultimately to Western Polynesia, Tonga, Fiji, Tonga, and Samoa, about 3,500 years ago. And then at some point spread out from central Polynesia out to all of the islands of East Polynesia, of what's called East Polynesia. People who got to Rapa Nui are also related to the other people who got to these other islands. So what we find is languages that are shared amongst Rapa Nui, the Marquesas Society Islands, Hawaii, and New Zealand. They all have very similar languages, very almost, they share a lot of words together, let's put it that way, and they share a lot of the grammar. But it's part of the same occupation that happened about 850 years ago, sometime around there. People get across East Polynesia and ultimately to Rapa Nui. So the sequence of sort of the understanding the chronology of this place, like when people got there, is useful to understand. And as I mentioned, about 800 years ago, humans arrived on Rapa Nui as part of the last expansion of people out of East Asia across the Pacific. In 1722, Europeans arrived on the island. So a lot of our knowledge about the island obviously comes from European encounters that begin in 1722. And the Dutch were the first to arrive there. A Dutch captain known as Jacob Roggeveen was searching for lost continents in the Pacific. They ultimately were looking for Australia. And he was searching around in the Pacific for a continent and came across this teeny tiny island. It'd been reported by a pirate as this low sandy island. And so he was following that claim, trying to discover what this pirate had found. Well, he didn't actually, couldn't find the low sandy island. He encountered Easter Island. He arrived on, or basically Easter Sunday, and that's why it's called Easter Island, as Europeans call it. the indigenous people who live on the island today and are descendants of people, the Polynesians that arrived there, call the island Rapa Nui. So I'll use the word Rapa Nui generally, but most people think of it as Easter Island. That's what we often call it. But it comes from Jacob Roggeveen, the Dutch captain who got there in 1722. Now, there's been a lot of stories about Easter Island that often people have learned in different in classes and books, that this island was sort of a site of catastrophe. There's sort of this air of it. And the reason why is when Europeans get there in 1722, they find people on the island. They're sort of shocked. Oh, this tiny little island that we didn't know existed, and there's people on it. And in addition, they find these gigantic statues, which we're going to talk about. And what they don't find is a lot of vegetation. The vegetation is really gone. There's no trees there. It's very sort of grasses and shrubs and stuff like that. But yet they find these gigantic statues, and they wonder, how did this come about? How can we have these amazing statues at the same time we have no vegetation? What happened? So they put these two and two together and said, well, in order to make the statues, they had to cut down all the trees, and that led to this sort of ecological desert, this lack of trees. There's a story, it comes that, well, the population wasn't very large. When Europeans get there, there's about 3,000 people on the island or so. It's a small number. And for a European, they thought, well, how could only 3,000 people have made all these statues? The assumption was, well, there used to be lots more people, and something happened to all the people that used to be here, and they kind of put the ecological disaster, the small number of people, and said, this was a total, collapse of this population. So the story often goes is that there was a native palm forest, populations grew like they always do with humans, just more people, and started making statues. These statues, there were more and more of them. In fact, what we're going to talk about, there's almost 1,000 statues on the island, 600 of them out of the quarry, and we'll talk more about that in a bit, that this was sort of a crazy number of statues, and that must have been a mania. People went bananas and made statues all over the place, and that resulted in ecological destruction, and then people got angry at each other, like, you have some food, I'm going to take your food, and started fighting with each other, and ultimately, the worst of all, they started eating each other, and it was this horrible catastrophe and this collapse. And so that's a lot of stories that you may hear about Easter Island are framed in this sort of story about ecological disaster. And what archaeologists and what Europeans saw when later on when people went to the island, they typically see statues, and again, these are the moai, the large statues, and they're fallen down. They're all, things are not in the original. They're not standing up. They're in this state. And so they said, this is evidence of this collapse. And the question is like, well, this obviously is what the story was. Well, part of my research has been sort of examining that and sort of trying to figure out, is this really the case on Easter Island? And I'm not going to spend a lot of time in this debunking this whole story, but I just want to sort of highlight that story before I talk about our own. Basically, this map model is that people get there, and sort of some graphs, looks like data, but it's just representations of people get there and populations grow. Europeans arrive, and that's where the pink shows up. And then populations collapse because of European arrival. And European arrival has a big impact almost everywhere Europeans go. In populations that are isolated from them, disease and other things cause population loss. But over time, when people are there, we can see palm pollen, and we can actually measure the fact that the trees went away over that period of time. And we can actually measure that archaeologically. We can go collect samples and look through time, and actually we do see palm forest. And then we see, and there's climate's changing at the time, and we see definitely conditions where it's drier conditions sometime around European arrival. But the argument basically looks like this, that the island used to have a lot of trees, then people came and there were fewer trees, and then there were a lot more people and a lot fewer trees, and eventually there's just people, and there's very few people as a result of the warfare and all the terrible things that happened there. And that's kind of the standard story. This is made popular by Jared Diamond, who's, I don't know if you guys have read Jared Diamond. He's written a book called Collapse, and he makes this big claim about, these people did this terrible thing and they collapsed. And he says Rapa Nui is the clearest example of a society that destroyed itself by overexploiting its own resources. Now, it's a good message. I mean, it's definitely a message for ourselves, like we should worry about the resources we have and the impacts that we might have on it, that we over-consume things and we over-harvest things that could be very negative to us. Certainly a good message. The question we will have to ask is, well, is this also the case for Rapa Nui people? Did they do the same thing that we're worried about ourselves? there's a great movie, if you ever get a chance, it's called Rapa Nui. It was produced by Kevin Costner. It was filmed in the 80s, and it had an interesting effect. It was filmed on the island, so if you watch the movie Rapa Nui, I think you can get it on Netflix or something like that. You actually get some great views of the actual island itself. The movie itself is terrible. Like, the whole story is terrible. Some hilarious things. Jason Scott Lee plays a Rapa Nui guy. Here he's on a stump, wondering what happened. Why did we chop all those trees down? Of course, he's not Rapa Nui. And all the actors in there are from New Zealand. They have New Zealand accents, and it's really funny. But anyways, it's a beautiful view of Rapa Nui if you want to see what it's like. Now, the research that we've been doing is actually quite, really changes the story. In our research, we started collecting data from the archaeological record, as archaeologists do. We wanted to see, well, what do we find archaeologically? That's a great story, but did this really happen? Did we really see warfare? Do we really see loss of populations? Do we really see the consequence of ecological destruction? What do we see? And the story we find is actually really the opposite, completely the opposite. That we find, of course, people get there, and once they arrive at 1200 or so, the populations grow. But we don't see it growing to some ever gigantic number. It actually goes, and it looks like populations go to about 3,000 people. That's sort of a stable number of people. We don't find people crammed into every corner. We find kind of a dispersed settlement system where people living all over the island at pretty low densities. We do see a palm decline. We do see the loss of palm trees. There used to be large palm trees on the island, huge, gigantic palm trees. These trees are probably related to what's known as the Chilean wine palm. Jubea chiliensis is the name of the palm tree. And those palm trees go away over time. The interesting thing about palm trees is that they're not necessarily things that people need. So often people think, oh, the forest is gone, that's terrible for people. The question you have to ask is, well, are the trees important for people? And in the case of wine palms, they're not, because the people on the island, in order to survive, they grow sweet potatoes. Sweet potatoes are basically the primary crop that Rapa Nui people made or grew. In order to grow sweet potatoes, you have to clear the palm forest to create land in order to grow sweet potatoes. So what we're actually seeing when we lose the palm trees is really the effect of people clearing the land in order to have more food for people. It's actually the opposite of what people say about ecological disaster. So what we see is a loss of palm forest, but in fact a very stable population, and that by the time Europeans arrive, they're seeing a very intact population at its maximum, which is only 3,000, and not a population that had suffered destruction and collapse. We see very much the opposite. So a quick story about that, which isn't really the interesting part isn't the coolest part of the archaeology, but it's sort of a lot of stuff that we have to do as archaeologists, try to figure out the own narrative. Now, one of the interesting things about the way people live on the island is that we often think about people living in villages and everyone's compacted a village all together with a bunch of houses. What we see when we look at the settlement patterns is that fact that people are living actually kind of spread out across the island in sort of patches across the island. It's low density settlement occupation. And one of the things that archaeologists do is we walk systematically over big swaths of the island, and we map where things are. We find, oh, there's a house here, there's an oven there, there's some stone tools there, and we map them very systematically to try to figure out where things are and try to understand the community. It's sort of the job of the archaeologist, sort of make these maps. And what we find is that there are places where these statues go, and these things are called ahu, platforms that statues are put on top of, these moai. And then there's housing, domestic kinds of activities, houses, gardens, and things like that spread across the landscape. And each ahu sort of has sort of areas of the community spread around it. So we're not finding dense, compact village kind of occupation. What we find is a very dispersed settlement system where people are kind of living over a large area. Living over a large area makes a lot of sense when you're living on a small island. It's a little counterintuitive, because what you do is you're maximizing your ability to get resources regardless of the environmental conditions that you're living in. That you can always get some plants that grow somewhere that are good enough for you to be able to survive. Now, on a teeny tiny island where there are no other islands around, you need to make sure that whatever you grow, wherever you grow stuff, that it's always going to produce food, because you have no choice. There's no other island you can go to if you run out of food. So what you do is you make sure that some food somewhere always grows. And what we're seeing is that people are using this environment very smartly in a very sustainable fashion that enables them as a community to survive for 800 years about until Europeans arrived there. A very different kind of settlement system than what people have often assumed must be there. It's a very stable system, and it's a system that you would expect in kind of environments that are remote and not necessarily rich in resources. So the cool thing about now that's sort of the background of all this. The cool stuff is really this amazing archaeology that's there. The moai and the platforms called ahu. So each of these things is called a moai. They have hats on top called pukau, and they're sitting on top of constructed platforms called ahu. Each community, and there's quite a few of them scattered around the coast, constructed these platforms and brought these moai to those places, and they were kind of the center focus of each community. So you imagine a whole bunch of different communities. There's up to 150 different communities spread around the coast of the island, each of which had an ahu, that many of them had moai put on top of them. Now this particular ahu is called Tongariki. It's on the south side of the island. It's one of the largest one. It's certainly the largest one that's been reconstructed. There are 15 statues on here, and they're immensely gigantic. I mean, it's hard to appreciate how large these things are. This statue is 10 meters tall, 30 feet tall. It probably weighs about 60 tons. It's a gigantic stone statue. But this impressive monument is kind of the core and sort of what makes Rapa Nui or Easter Island so mysterious. That here's this teeny tiny island, very small population. Now we know maybe 3,000 people building gigantic things. And, not only carving statues, moving lots of statues, and then putting them on top of these platforms. So really just remarkable achievements. The real mystery to Easter Island, first of all, is understanding the community and understanding how they survive. But how did they do this? How was it possible that they were able to carve these statues and transport them across this landscape to get them to these ahu? Now, as I said, there's nearly 600 statues distributed across the island, huge number. So they invested a lot of energy into this effort of making and carving these statues, which meant that the statues themselves were very, very important to them. They were very essential because they did this over a period of 800 years. We suspect they did it by the time early when they arrived, and certainly up until European arrival in 1722. So how did they do this? Well, of course, some people say that couldn't have been them. It couldn't have been Rapa Nui people. It was aliens, because the only way that anything gigantic like that could have been done is moving by aliens. It wasn't aliens. It was Polynesian people. And we know that because we can look at the archaeological record and see the tools that were involved with carving them and moving them. So anyways, that's the story that often gets told. My colleague, Terry Hunt, who's at the University of Arizona right now, and I started in 2000 there. When we first got there, we decided, well, there's been so much speculation about these statues and how they were moved that maybe we shouldn't, let's not study that at all. Let's avoid that question, because people could have moved them in lots of different ways. There's lots of plausible, possible ways you could have moved it, but how are we ever going to know? Because the statues are there, and now no one wrote down how they did it. Europeans, when they first got there, didn't think to ask, how did you move these statues? So it's sort of this information could be lost forever. And so let's avoid that. But as we were walking around doing the surveys, looking at the communities, we realized that there were some things about the statues that we couldn't explain, that didn't make any sense in where we found them. So we started doing systematic studies of the moai to figure out, well, what is it about these things that might be telling us about transport? So here's some of our mapping here. We mapped there's about 904. We mapped about 942 statues during the survey, and we found that there's kind of three kinds of statues, or three places that you find statues. Let's put it that way. There's the quarry, where 95% of the statues are carved, called Rano Raraku, and it's a volcanic vent. And I'll show you some photos of that, some 3D modeling. There's statues at the ahu, which are the green dots, and those are the places that the platforms on which statues were placed. And those are distributed across the island, mostly along the coast, with some inland ones. And there's those statues on the ahu. And then there's the red star statues. statues that are found in the interior on roads. And these roads are constructed features made by ancient Rapa Nui people that were made in order to transport the statues. And we noticed that the statues along the roads, these red stores, were different than the ones that we found in the green dots. And that puzzled us. Why are the statues on these places different than the ones in the Ahu? Let's see what we got going here. So this is the quarry. This is the place where many of the statues, 95% of the statues are carved. It's a big volcanic vent of a volcano, the Poike volcano. It's a sort of a place where ash at one point shot out of the vent. The ash fell down and actually was submerged, was under the ocean at the time in which it formed. That ash fell down and sort of built up around it and then got compressed, and it's that material that statues are carved from. And in fact, all the statues that you can see are actually carved up here on the slopes of the cliff. This is Ranaraku, which is Maungaio, but located right there in that corner of the island. Now the quarry is just chock full of really cool information, because here's the place where people made these things, and we can learn a lot by studying them. And even on this photo, you can see there's sort of a lot of details about the statues. The statues are just often people see photos of statues and they see them up to their heads. They just see the heads part of them. And those are statues that are down here that have been carved earlier and then brought down to the bottom of the hill. The carving actually occurs up high on the cliff. It's carved. These things are carved, like you can see a statue here, and there's lots of carvings up here, up high on the cliff. And once they're detached from the bedrock, they're slid down the hill and then placed in an upright position in order to be finished. That they needed in other words, they're in trenches at the bottom so they can be the rest of the carving can be done. Now, when we look around on the ground around those, as an archaeologist, you spend a lot of time looking around at your feet and seeing things whenever you go. You can actually find tools that you find hand axes called toki, are hand axes that are, something like this, about big, that are made out of a dense basalt or a volcanic rock that's stronger than the material that they're trying to carve. And these are the tools that people use to carve the statues. And there's really no question about people carving statues, because you find the holes where the statues were, you find the tools that people used, it's all there. And so if the archaeologists, can put the two and two together and figure out this is how they were made. As I said, the statues were carved up above and then brought down the hill, slid using gravity to get down to the bottom of the hill, and then stood up in order for them to be finished. Now, one of the challenges, let's see if the next slide is, one of the challenges that Rapa Nui carvers had is that as you carve a statue, you have to disconnect it from the bedrock. And statues are carved face up such that in order to finish it, you have to carve underneath it to crack it off the bedrock and then slide it down. What that typically means is that underneath the statue, there's a big V section where both sides come together. And in order to finish the statue, you have to get rid of the V to finish the back, otherwise it has this really weird sort of fin on the back. So they're standing upright and they can carve the back of the statue. So all the statues were standing at the bottom to be finished, and that's why they're sitting there. Now what happens is some of the statues then are abandoned. They're like, oh, this isn't going to go anywhere. And sediment fills in, and then they end up with just the head sticking out. So the New Yorker cartoons that you always see about statues' heads are basically because it's a version of this. But all these are full statues, and people have known that for 100 years, or more than 100 years. And it's pretty, it's just a characterization of the statues at the quarry at the bottom. So here's the process that we've constructed. The statues are carved first up here, up high on the cliff. They have to be carved from kind of the back side. They have to carve underneath. So it creates kind of a keel where they have to carve and get themselves under. Probably the scariest part of carving a statue is you're carving down. You have to get underneath it, and then eventually both sides come together and it breaks off. And then it slid down the hill, and it's sort of represented here, this sort of keel, because that's the part where it used to connect to the bedrock. Slide it down. It goes into a pit. Then you shave off the backside till it gets to the right form that we see at the Ahu. Sometimes they're abandoned, and then those fill in, and that's why we see just the head. So that's really the construction. You can really easily see that at the quarry. I mean, there's all the steps of that. There's about 400 statues in various states of being constructed at the quarry, so you can see all of that.
What would the timeline be like, sort of start to finish?
I wish we knew. I mean, the hard part is, we don't know how many people were involved at the same time. So like, a lot of people, there probably is a limit to the number of people because you couldn't get that many people around it to carving. But it's really hard to estimate. The material isn't super hard. The ash is sort of compressed. It's kind of like a sandstone, I guess, is the way you think of it. So it breaks apart pretty easily. But it was certainly on the order of months, if not a year, to carve a statue. I mean, certainly a lot of work. They're big objects, so a lot of volume to take off around it. But yeah, it's a good question. That's one thing we've always wondered. It's like there must be some boundaries to figure out. It must have taken at least this long, and then of course it could take us much longer. Once they get to the bottom of the statues, they're then transported out of the quarry across roads. And what we find are statues on roads sort of in the direction in which they're traveling, fallen, that were sort of abandoned along these roadways. And that's a really important thing, that the roads themselves have statues that were in the process of being moved, but then something happened to them and they were abandoned. Now, our observation there was starting to look at the road statues, those red stars that we saw on the map, and we started to notice that there are lots of interesting features about those statues on the roads. That the statues on the roads, unlike the statues at the Ahu, because they think the statues at the platform are standing upright. In order to stand upright, they need to be nice and straight up and down. The statues along the road, in fact, have an incredibly forward lean, that they're leaning really far forward such that they wouldn't stand up if you stood them upright, which has really puzzled us. Like, why would you make a statue that can't stand up if your goal is to get a statue to a place where you're going to stand it up? Didn't make any sense. We often find large D-shaped bases, the big curved bases and flat backs, and we wondered why are these front bases curved the way they did. We also saw the statues were broken in interesting patterns. Statues that were, we typically, when they were fallen, heads would be rolled off, right? So suggesting some kind of force that was involved. We found lots of fractures. I'll show you an image of some fracturing and sort of the way they broke. And then we also found this non-random pattern, that statues that were going away from the quarry uphill would be on their backs, and the statues going away from the quarry going downhill would be on their front, which kind of points to the fact that statues were in an upright position in order to get to that pattern. So all these things came together, and we thought, that's really odd. Like, something must explain that. So we did some 3D modeling of statues, and one of the things you can see here, sort of this is one of the statues along the roads, about 70% of the statues along the roads have gigantic flakes off the edges, huge flakes that are off this side. The only way you can get a broken piece like this is that there's a huge amount of force right on that edge that cracks off this piece, which again points to leads us to think, well, this evidence that we're seeing here suggests that the statues on the road got there because they were first standing up and then fell over. That they had to have been standing to have gotten all these features.
Idea has the virtue of being consistent with oral tradition. In fact, the Rapa Nui language even has a word, neke neke, which translates as walking with no legs.
For centuries, we have known that the moai did walk, as our ancestors said. But how exactly they did the walking is what we, the archaeologists, are looking into.
In fact, others have tried to move them vertically, including Thor Heyerdahl and a Czech engineer named Pavel Pavel.
This is the statue that Pavel Pavel tried to move in 1986 with his experiments, moving the statues in an upright position.
By shuffling it across the surface, there was a lot of friction on the base. And as he did it, in fact, there was damage done to the base that removed material right down from the bottom here. So we thought this can't really be quite right because the shuffling and the grinding isn't consistent with what we saw in the statue. So on the one hand, we were like, yes, they're moving standing up, but not exactly that way.
To figure out a less destructive way to move them, they built on observations first made by Sergio Rapa, identifying differences between statues that made it to the platform and those that fell on the way. On the more than 50 fallen statues they analyzed, what researchers called road moai, the eyes hadn't been carved yet. They were left as sharp-angled slots. According to Hunt and Lipo's measurements, road moai were chunkier. Their bases were bigger. Their centers of gravity were lower, kind of like a bowling pin. Most of the road moai had a D-shaped base, and the base was angled so the statue leaned forward. These were key features to Lipo and Hunt.
The statues were rolled across the front edge. And that front edge has a characteristic shape, especially as the statues get larger, that allowed that to happen.
The statues that made it to the Ahu platform showed the difference. The eyes had been carved, their sides had been trimmed, and their center of gravity shifted back and up. They'd been cut so that their bases were no longer angled, but flat. They leaned forward, but not as far as road moai. They stood more upright, and they'd lost a little weight. Based on all these differences, the difficulties faced by the Czech engineer Pavel are understandable.
Pavel was using a statue that had already been reshaped for a platform.
The eyes had already been carved. It didn't lean as far forward, and its sides had been trimmed.
Ultimately, the evidence for how the statues are moved can be found on the statues themselves. They were engineered to move, and the details of the statues are telling us about transport.
Okay, a little clip from the Nova special we did. The evidence from the archaeological record really points to the fact that the statues are in the standing position, and the only way we can explain that is the fact that that's the only way we can explain why we see the features we do on the statues in this upright position. Now, Terry and I wrote this book called "The Statues That Walked," that would sort of put all this archaeological evidence together back in 2011, I think the book came out. And we were like, okay, we've gotten all the archaeological evidence, we've done all these detailed studies, we've clearly sort of put it all together to demonstrate that these were moved in this walking fashion, which was great in this book. But Nova came to us and said, that's fantastic. Why don't you do that? Why don't you move a statue for us and show how it's actually done? And initially, my first thought was, no way. We know how they're moved. We can explain the archaeological record in the same way that an aircraft engineer knows how a plane flies, but you don't want an aircraft engineer to fly the plane, right? You want the pilot to do that. The actual effort of moving something is going to require knowledge of the ropes and all the different features. It's going to be different kind of knowledge than we had to do. But they said, no, you got to do it. So we're like, okay, if we're going to do that, we need to build a road moai. We need to build a moai that's exactly like the statues that they moved, and that statue that's found along the roads. So we did what's called photogrammetry, where we took a bunch of photos and built a three-dimensional model, which is an exact replica of a road moai. That was sent to a company that made a mold out of that, and then filled that with concrete, and then made the statue itself. And of course, because it's TV, and they wanted us to do this experiment or this demonstration, they shipped it to Hawaii in a giant box and opened it, and they said, okay, now move this statue. And we were like, holy crap, we have to move this gigantic statue. And so if you watch the Nova special, you'll see all of our struggles trying to do it systematically, but it was certainly very non-obvious exactly how to do it. Like, we knew it had to be standing, right? We knew it had some ropes in some way, but exactly how you did it was something we had to sort of figure out while we were doing it. So we built this statue. It's about 10 feet tall, a little less than 5 tons. We called it Hotu Iti. And the concrete was filled with some foam just to make it this similar specific gravity as the statue itself. But it's still there. If you go to Kualoa Ranch on Oahu, where they filmed Lost, and all the Pacific movies you ever see are always filmed at Kualoa Ranch, like Battleship, and I don't know, there isn't any Pacific movie that isn't filmed there. You'll see this statue. It's sitting there in the middle of the valley. It's now like shows up on people's, it's so funny, like we built this and now it's in tourist shots and people are like, oh, this crazy moai in this valley. It's like, no, we made that for this experiment.
Attached to the statue Hunt and Lipo
All right.
finally have a chance to test their walking theory.
So I'll just show you a little this video of us finally getting it figured out.
Starting out with team A, I want you to pull. Just the harder you keep it comfortable.
Oh, sorry.
Rock it a little bit.
So we tied ropes, and we tried different combinations of ropes in different directions to see if what we could get to work. Our goal was to use the least number of ropes necessary, to try to figure out what's the least number of people we get, and it didn't work at all. It did this a lot. We could rock it back and forth. The crane held it up.
How's that? You guys exhausted? Okay.
The teams continue to move farther and farther apart, simultaneously pulling and trying to twist the statue. But it's just not working.
So, in TV fashion, we were given 2 days to do this. They brought the box up and opened it. It was like half of the first day. So we had half of a day. And then the second day, we were trying all kinds of things. And it was 4:30 in the afternoon, and there was a crane there ready to pick this statue up and put it where it was going to go, and that was going to be it. And they started interviewing us and saying, like, so this seems like a failure. And we had to do the thing like, well, we've learned a lot by blah, blah, blah. Yeah. And we were like, but this is a total failure. Like, but, we knew we were still right, but we're like, well, we just didn't figure out the right parts. But 4:30, just before.
We just actually,
If you can switch.
Get
The audio?
to come through HDMI.
Oh, yeah. I'll get the system.
Yeah.
Here, oops.
Yeah, but just go to.
Come on, find her. Come on. Here. Where's the Gary? So teeny tiny.
Yeah, it's right there.
All right, there. Ah, all right. All right. All right, so it was 4:30. The crane was ready to go. We got the ropes around it and started with 3 ropes. This was the key. And suddenly the statue walked. Didn't work. There it goes, all on its own. The key was getting it leaning forward on its front edge with this rope in the back holding it from falling on its face. Once it's rocking side to side, it falls forward, but it takes a step each time it does so. There's going to be a switch here. Now, one of the cool things when we did this was we were working on Hawaii, and we had Rapa Nui people with us as part of the experiment, and sort of working with us. We got people from Rapa Nui, people living on Hawaii, and when they were doing that, they heard they're like, "This is amazing! Seeing this thing move is just stunning." Our grandmother used to sing this song about the statue walking, and we're like, "Really?" Because as we were doing this, we were going like, "I bet there was a work song that people had when they were doing this." And they're like, "Yeah, it was this song about walking the moai." And we're like, "Really? Like, let's get that down." And so we went to the island and we said, "Could you sing the song to us?" And we did that. We recorded this song, and it matches the walking in an amazing way, which we didn't edit to do so. It literally is like a work song. The song is about the king who has the knowledge about moving the statue. Tukoe is the king. Holding, clicking rocks together.
aro o te ariki ko papa hiro ko papa kirangi moai tau aro o te ariki nema ori ori tukoi me hakaha ere ere moai nema ori ori tukoi me hakaha ere ere moai ka mautero ngorongo ka tukoi were 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 nema ori ori tukoi me hakaha ere ere moai nema ori ori tukoi me hakaha ere ere moai nema ori ori tukoi me hakaha ere ere moai nema ori ori tukoi me hakaha ere ere moai.
Isn't that amazing? Yeah. So, yeah, it's really incredible. It's hard to believe this thing went from this immovable object, and we struggled, you know. You couldn't shake it at all. It was solid, into something that was like dancing down the road. I mean, it really blew me away. And really what it is the ingenuity of Rapa Nui people who used the center of mass and positioned it to this point of instability so that as you rock it side to side, in the front rounded edge, it takes a step. It's basically just using the physics of the object itself in order to enable it to walk. It's not unlike the way we walk in the sense that we pivot and fall on with our legs. It's, you know, uses the same kind of principle. It literally walks, and it's just stunning because it goes from something that is hard to believe that it moved at all into something that really can do very easily. We were able to move about 100 meters in 40 minutes. You know, it really didn't take that many people. It's very consistent with small numbers of people participating in this, doing this very efficiently, consistent with what we're finding in the rest of the archaeological record. Not lots of people, not tons of resources, something that was totally within the scope of what the Rapa Nui, what we find in the archaeological record about the island. So this was on the cover of National Geographic. It was really cool, in sort of some artwork there. You know, this it sort of really reframes this idea of this island and these people and what they're doing there. That they're doing stuff certainly within the constraints that they had available to them and the resources that they had. Now, I want to talk quickly a bit about some of the other stuff we've been working on since then, just to give you an idea of like some other things that archaeologists do. Rana Araku, of course, is, as I mentioned, is the source of all the statues themselves. This is where they're being carved, and people have known about this and sort of discussed it in a lot of ways, but we don't really have good detailed information about it. Partly because it's really complex. You've got this essentially mountain with all this information across it, and how do you document something like that? Drawing a map, like a map is two-dimensional. How do you capture three-dimensional things? So we're going to the island quite often, and you may have heard about this in 2022, where there was a grass fire that burned an area around the quarry, and people were very concerned about it. That says, you know, leaving statues totally charred, that, you know, might have damaged the statues. And the community on the island asked us, say, well, can you help us document the statue, the quarry itself, in order to figure out what damage there might be, and for the future, if something happens, how do we know there's been changes to it? So what we did was used quadcopters, small DJI quadcopters, in January and then again in July 2024. We flew more than 20,000 photos in the first time, generated an immense number of photos over the area. The quadcopter flew over it, back and forth, took 1 million photos together of each one. Each photo was overlapping with every other photo, and then we combined them into a gigantic model, and then the computer stitched everything together to create a 3D model. Ta-da, here. So, and let me jump over to, let's see, switch here to, so we've been doing this all over the island, but here's the quarry. You can zoom in here. This will take a second to load. So we were able to create a three-dimensional model of the quarry at centimeter resolution to document everything about the quarry itself. And what's amazing is you can see all the details of where things were being carved, where things were abandoned. A good example of that, the keel thing is here. Zoom in here. Boop, boop, boop. You can see the sides where people are carving in on both sides. They have to carve the keel before it cracks off and slides down. You can see all kinds of information, different statues of different sorts, other kinds of blocks being carved up high on the cliffs where statues are being prepared. And you can see stuff that you can't actually see on the ground because it's too steep and it's too, it's impossible to get to. All these are carving blocks that were being carved by people. And even, in fact, most of the statues, let's see if I can find it here. Where is she? Where is that statue? Oh, statues, well, actually, I'll show you this way. Here, turn around. Boop, boop. Statues are actually being carved on the outside of the quarry, of the crater, as well as on the inside. It's almost like a video game. So we were able to document this archaeological record in ways that really couldn't have been done in any other way, and being able to now study this and we can make measurements from this. We can document all the details of carving. What we've learned is that there's multiple carving strategies that they took at different places, had different carving strategies, where some of them the faces are first, other ones they're carving into the wall, and sometimes they're carving in blocks and then carving pieces out. So we're learning a lot about the details of carving and all the things that went into it. Let me switch back to this. Here. We're doing this, of course, for a lot of the archaeological record on Rapa Nui to learn more about its 3D strategy. Now, one of the interesting things we learned is that statues are being carved in sort of in sets that really represent sort of a workshop, that a group of people are consistently working in this area that are separated from other areas where people are working. So we see sort of a combination of statues, sort of almost an Escher-like landscape of statues being carved here, 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 all over the place, all being carved in this one space, and that's separate from other spaces that people are carving the statues. This sort of mapping of this kind of points to the fact that the carving, the quarry itself, wasn't a gigantic factory of statues where they're pumping one out at a time, that multiple groups are working simultaneously across the quarry, which is very consistent with these different communities living around the island. Each of the communities had their places that they would come and carve, and that is, again, consistent with the sort of community pattern that we talked about earlier. Things that we can learn from the 3D model. Now, one of the questions that sort of last question, I'm just going to quick go into this, it's going to leave it a little bit of cliffhanger here, is we wanted to ask the question, well, where does this idea of ahu and moai come from? Like, why did people do this, and who thought of it first? We know it's Polynesian, but where did the Polynesians get it? How did this come about? So we started to ask that question. Now, traditionally, people think, well, East Polynesia is this big triangle here where everyone's related to each other, and they're all part of the same expansion of people out of Central Polynesia. That the homeland of this was somewhere in Fiji, Tonga, and Samoa, sort of this Western Polynesia. And that's, of course, where people in East Polynesia were definitely related to West Polynesia. And the assumption is, well, maybe they're all from Samoa. Samoa's a big island. There's lots of people. Maybe that's the homeland. And that's always been the traditional story for East Polynesia. The problem is, if you go to Samoa and you look as an archaeologist, and you look at what's going on in the 13th century when people are getting to Rapa Nui and elsewhere across the Pacific, is you don't find statues. You don't find the same things that you see across East Polynesia. What you find are star mounds, these really interesting mounds shaped like stars, and big platforms and things like that. Not statues, not ahu platforms constructed in the same way. Very, very different archaeology. So you think, well, in order for people as Eastern Polynesian to have brought this idea of statue construction with them as Polynesians, they had to have had it first somewhere else to bring it there. And if it's not here, then where is it? That's not the homeland. Where could it be? Well, interestingly, this guy, William Pila Wilson, is a linguist at the University of Hawaii Hilo. And he wrote this paper back in 1985 that a lot of linguists are going, this guy's a nut. He doesn't know what he's talking about. And he argued that the evidence, this paper, evidence for an outlier source of the Proto-Eastern Polynesian pronomial system, like everyone knows exactly what that means, demonstrated that the homeland of Eastern Polynesia, which would be Rapa Nui people, was actually in what's called the outliers. And people traditionally, even today, thought that's crazy. That's no way. It must have come from somewhere. There's no way it could be. Now, as a linguist, linguists study language, and languages are really interesting because you can kind of study history of people through languages. And they think of them in sort of nested fashions, that sort of the more distant a language is, the less similar languages are, the older they must be to have split apart. That languages that are closer to each other, the more closely they were, more recently were they related. And they kind of look at these things in this kind of nested set. So we've got there's sort of this pattern that they're sort of managing. You don't need to worry about the details of that, but understand that there's sort of a language thing going on here. And what he argued was that that these central northern outlier populations here, not Fiji, Tonga, Samoa here, were actually the homeland based on language. He said that these languages here are more like the ones you find in Hawaii, Rapa Nui, Marquesas, Tahiti, New Zealand, than the ones that are over here, that the ones in Samoa are more different from that. And it's, if you're interested in languages, there's all kinds of cool stuff studying languages. And a good example of this is the word ta'e, which means poop. And so so the word is sort of, the root of the word is ta'e. In the central northern islands, they say tuate. In Hawaii, they say kuake. The consonant changes from T to a K. In Tahitian, it's tuate. Maori in New Zealand, it's tuate. But in Samoa, it's more like the original form, this old form, that the languages between central northern outliers, those islands way over there, are closer to each other than they are to the Samoan language. That really suggests that these things are more recently connected than the Samoan ones. The Samoans are connected through an older time. Really interesting study. He found that there are about 200 words when he looks at the language that you can't explain in terms of the timing of when they split apart. So he's found these systematic patterns, lots of these shared innovations that you find. The innovations are similar between these two islands. And they find 200 of them, lots and lots of cases of this. That isn't chance alone. Sometimes words can be similar to each other just by chance alone. But in this case, there's too many for that to be chance. So what he argued is the fact that the old model was that people, Samoan and the outliers were all basically one, and that people went to Eastern Polynesia from Samoa. This new model, he said that in fact the Samoan languages are separate, or earlier that people first went from Samoa, then they went to the central outliers, these islands to the west, before they went to Eastern Polynesia. So there's this total different sequence. It's a better way to show it as this map. The old model basically said people went from Samoa, and then they went out to Eastern Polynesia. This was the homeland, and then the people spread out. His model, from the language, says that no, people didn't go from Samoa. They are related, but they went back this way, west, and then from these teeny tiny little islands way out here near the Solomon Islands, then they went all the way here to the Marquesas, and then they spread out. Very different model, totally different model, that all of the people from Hawaii, New Zealand, Rapa Nui, and the Marquesas are actually related, mostly related from these teeny tiny little islands out here. Easter Island is here, Rapa Nui. Yeah, way over here in the eastern, it's the most easternmost part of Eastern Polynesia. Now, interestingly, when you look across Eastern Polynesia, you find a lot of things that are like what you find in Rapa Nui. Platforms with stone uprights. And you find this in the Tuamotus, platforms with uprights. You find them in Hawaii. This is up on Mauna Kea, uprights and platforms. Actually, Mauna Loa is where that one is, on the Big Island. You find this on Rapa Nui. In fact, you find these big uprights at the base of some of the ahu that are being constructed here. Stones that are standing upright that later then have additional things added on top of them. So these big uprights are connected together. In fact, when you look across East Polynesia, you find stone uprights all over the place in Eastern Polynesia. Now, so what does this tell us about where the idea of ahu and moai come from? Well, if Pila Wilson is right, it's possible it's coming from these teeny tiny islands way out here. Way out here, really far away from the rest of Eastern Polynesia. To get from here to Hawaii, there's a lot of similarities in language here. It's thousands of miles away. To get to Rapa Nui, we're talking, a third of the Earth to get from there to there. Just crazy. How is this possible? Is this possible? Is the homeland the Central Polynesias? These islands are called Nukumanu and Onton Java. Now, the interesting thing is and linguists have said this, well, in order for people to figure this out, someone needs to go there, and study this, right? How do you get there? Well, it turns out no one's ever done any archaeology there for any purpose. No one's ever been there. It was like the 1930s when anthropologists were there. In fact, the people who did the most sort of descriptions of the island and the people living there were the Germans in 1907. So it's been a long time. No one's been there. And today, there are no planes to go there. There's no freighter. There's no ferry. There's no way to get there. So how do you get there? Well, we decided we had to do it, right? We had to go because in order to figure this out, we got to go to this island and see for ourselves. Now, this is the world's biggest atoll. It's about 50 miles in circumference. It's a humongous atoll. Atolls are volcanic islands that the center of the volcano sinks over time, and the reef that was around the volcano is all that's left of it. And what we have is a coral reef that's this giant circle, and both of these things are these coral atolls. Very thin islands, only a couple hundred meters across, but very long. But what we find on those islands is stone uprights. Stone uprights that are unique features in Western Polynesia. You don't find them anywhere else. These something are very distinctive. And they represent ancestors. They represent the same thing that we find on Rapa Nui and elsewhere in Eastern Polynesia. So we had to go there. Other things we also find on Onton Java, these islands, are human representations, human figurines that are carved. So the question is, are these things related? Is this the source of the ideas from Rapa Nui? So we had to go there. We were able to get a donor to help support us, and we chartered a tugboat, a tugboat from Honiara, from Solomon Islands. This was a ship that was in the Sydney harbor in the 1960s as a fireboat, and then converted into a tugboat, and then brought over the Solomon Islands. And we lived over the summer. We spent a month on this vessel, going off to Onton Java. So we were very happy when we got everything worked together. We had to get a very generous donor to support chartering this boat. We very happy because we were on a boat. And we set for sail on our adventure there. But of course, we didn't, wear that. That was an AI-generated version of ourselves. So we were living on this boat. It was pretty rustic, I have to say, because it was a fireboat and kind of boat that you bonk your head on everything where you go. And we went out to this island, and it turns out there are people living on these islands, about a couple hundred people living in a village of Luangia, and they they live on the island. Basically subsistence life. They have a cash economy, which consists of free diving for sea cucumbers that they then boil and then sell to Chinese freighters for medicinal purposes. That's their entire cash economy. Sort of very interesting group, very subject to climate change. So sea level is really a threat to them because they're only a meter above sea level. We went there. There's a village there on the island. Really fantastic people living on this. Was our summer trip, living in houses made of coconut fibers. Sort of the typical, the classic Polynesian island, in the desert island in the Pacific. Fantastic, friendly people. We were excavating. And we excavated. We dug down. We found a shell midden. So here we have this challenge of this gigantic island, and we have to dig a hole to see if we can get material that's going to point to Eastern Polynesia. And what we were looking for specifically to find, is there evidence of people living on this island at a time, that have connections to Eastern Polynesia at a time that predates the arrival of people in the rest of Eastern Polynesia. So the radiocarbon dates are the most important to us, for us to figure out, see that we can have evidence of people living there before they got to East Polynesia. Because if people only arrived there after East Polynesia, then the old model would be right. If it's before, then the new model would be right, and this is the place that they went from. So we had to find a place across this gigantic island, pick a spot, excavate, dig down to the very, very bottom to find the very earliest deposit of this occupation and get some material to send off for radiocarbon dating in order to get a date. Now, radiocarbon dates are basically based on plants and animals that die, and basically you can date those plants and when those things died to the point at which basically they're removed from the carbon cycle, which enables you to date them. So we had to get a piece of charcoal that was from the very bottom. We got to the very, very bottom. At the point at the very bottom here, we were actually below the high tide line. The water would come up during high tide, so we couldn't get any lower because you couldn't live any lower than that, because originally all this deposition is stuff that's piled up over time after people first got there. People dumped a bunch of stuff in there. We collected artifacts. At the very, very bottom, we found gigantic shells, which is interesting, really telling. Often on islands like this, the shellfish are really gigantic when people first get there, because before people are there, the shellfish are happy, growing as big as they can get, and then people show up and they eat them and end up being much smaller. So it looks like it's very early deposits. We got the charcoal dates, but we don't have the answer yet. The big question is, what is the date going to be? We just sent the samples out literally last week to a laboratory, and we're waiting anxiously to get the dates. We're very excited about what's possible, because it really will change the whole history of Eastern Polynesia. It provides an answer to, this is the homeland from which people started that went out to Eastern Polynesia. It's very counterintuitive, because these are teeny tiny atolls with not many people, not huge populations. But on islands like this, where people are living out very in remote spaces, they had to be good sailors. In order to survive on a daily basis, you had to be able to go other places to get information, to get resources, to get mates. All that stuff required long-distance voyaging. So if any place is going to be the innovators of long-distance voyaging, it's going to be a tiny place like this, where voyaging is going to be completely tied to your survival. So in fact, it actually makes, once you think of it that way, it makes more sense that these are the homeland, the original colonization people of Eastern Polynesia. But we've got to demonstrate it, and we've got to do this archaeology to figure that out. And we will get an answer really soon, and I hope to be able to share with that at some point. So thank you.
Oh my God. Please come back.
I'll tell you the answer, yeah.
When you get the answer,
Oh, absolutely. Yeah, this is going to be huge, because if it changes, it'll change the story. Like, basically, the ancestry of all the people of Hawaii and New Zealand will be different, which is really fantastic. But it answers this question, like, they must have had this idea to begin with. Where did that come from? And there are places to think where these things come from, but these islands make the most sense. We also collected rat bones. So rats are these Polynesian rats that were on Easter Island. They're rat bones at the very bottom, and there are particular haplotypes, genetics, that can tie it to East Polynesia. So we're going to do genetic sequencing of those rats to see if these rats are connected to those rats. And we have artifacts from there. There's lots of things to still do, but we're anxiously waiting for these dates, which is the first step. So
hold on. Let me just have you ask the question into the mic so that the people on the live stream can hear it.
Oh, okay. When you get the information, where are we going to look to find it?
Well, I'll be happy to come and talk about it. We'll make as much news about it as we possibly can, because it's cool. It's like this great mystery from this place that no one's been to. Like, it's hard to believe that there's an island anywhere that people haven't studied, completely. But it's so remote. It's impossible to get to. We spent a year trying to figure out how to even get there. Like, how do you charter a boat to get to this place, like who do you, it's not like you can look up Airbnb and, you know, rentaboat.com. You know, we had to, anyway, so it was very, very complicated. And so there's good reasons why people haven't gone there, but, you know, we figured it out, and we're very excited about that.
So what country owns those two atolls?
Oh, great question. The Solomon Islands. The Solomon Islands, they're atolls of the Solomon. Actually, Nukumanu, the one to the north, is owned by Papua New Guinea. The one to the south is the Solomon Islands. They're actually two different countries. So if we wanted to get to the other ones, we have to go to Papua New Guinea and then take a boat out there, versus Solomon Islands to take a boat.
Is there passport control as you come into?
We asked these guys. We were like, well, could you just go to the? Because we were waiting. There's a lot of politics. You can imagine lots of complications. We're like, oh, we just go to Nukumanu to see what they said. You know, and they said, well, we'll just go there and just say, oh yeah, we're waiting for the immigration people to show up. Of course, you know, they'll never show up. So we just do what we did. So, no, but we ended up working out here.
I had two questions. One is the stones themselves, the larger one. Are they like ancestors when somebody passed? What's the meaning of them?
Of the Antong Java ones?
No, the ones at
the Rapa Nui?
East, yeah.
They're basically ancestors. So
they are
I didn't tell the whole sort of frame that part of it. These moai are representative ancestors. They're carved. They have names, and they're potentially carved related to the death of somebody. They're slightly different from each other, but they're very stylized, so it's hard to know if it's a person.
It's kind of like a tombstone.
Not really. It's sort of like it's their representation, and they're set up in front of the community, and they stare at the community. They're there looking over the community. Often people think the statues are facing the sea, but they're actually facing inland because that's where the community is, and they're guiding and looking over them. And so they set up all their ancestors to give them wisdom and keep them safe.
My second question was like, you said you've been doing this for 25 years?
Yeah.
What got you into this? Like, why this?
The perfect mystery. Like,
okay.
In fact, Terry and I remember back in 19. Actually, I was a graduate student at the University of Washington, and we were talking over probably coffee or something in Seattle, and we started talking about like, why do people do? In the past, people did crazy things like. You know, so one of the greatest mysteries, like all these weird things that people did, those are things we need answers to. And we said, what's the greatest, why did people do this thing of all? Rapa Nui, Easter Island. Like, this is the most unlikely place to find gigantic statues. It's small, it's remote, populations were never very big, it didn't have resources. Why would you do that? And we desperately need to have answers because they did it for a good reason. It's not because they were crazy. It's because it mattered to them. Their survival depended on it. This is something that was really important to those communities. So we really wanted to answer those questions. And so it was sort of this burning, like, this is an interesting thing to solve.
So now you're looking into sort of why did they do it to begin with? Are there any indications for why they stopped? Or was the tradition lost?
So with the arrival of, things change rapidly when Europeans arrive for a number of reasons. You know, Europeans never see people carving the statues. Like, there's no reports of them carving or walking or moving the statues. And that's partly because when Europeans arrive, the Rapa Nui people are like, wow, look what's happened, because they're living on it for 800 years. They're on an island that's completely isolated from everything else. Their entire universe is that particular, you know, spot of land. So the arrival of Europeans with European goods and European hats and clothing and stuff was just, wow. So everything kind of stops at that point. So Europeans never see it. That doesn't mean that they're not doing it when Europeans are away, because there's often many decades between European arrival. But the economy starts to change. People start to value things in a different way, like European goods, as well as the fact that there's disease. Disease has a huge impact on these populations. They're isolated from Europeans. Europeans, at the time, didn't know about germ theory. This is pre-germ theory, and had been suffering from lots of different diseases. And so a cold to European was something that was a minor thing, but to Rapa Nui people, Eastern and many Polynesian islands, it was deadly. And so it really had its disease swept through those populations, which meant that there was a lot of population loss. So everything was sort of disrupted with Europeans.
I have a question. Are you familiar with the Kon-Tiki, the boat?
Yes.
Yes. I read that book a long time ago before I came to America, and it's about, I think, from Dutch or Holland, people who come together to make a boat like Moana, you know, with a couple of trees, you know. So they want to improve the theory that the people to the South America came from the island from Polynesia. Is that the Eastern Island or something else?
Yeah, no, this is Thor Heyerdahl, a Norwegian explorer. He had sort of believed that, people came from elsewhere to get to Rapa Nui, and he had this theory that it was South Americans. So to prove that, he built a boat out of reeds, and then he sailed out. He never actually got to Rapa Nui. He sort of got lost. But sort of demonstrate he could go long distance. There's no evidence that South Americans going this direction, going west. There is interesting evidence that Polynesians ultimately got in contact with South America in two ways. So, Polynesians went all over the place, and when they're sailing to Hawaii and to Rapa Nui, there's no question they probably kept going to some degree. And we know this because they bring the sweet potato with them, and sweet potato is the crop that they're growing in East Island. The sweet potato comes from South America. So we know at some point Polynesians get the sweet potato and bring it and spread it across South America. And we actually see some genetics in Polynesian people of South American genetics. It doesn't look like South American genetics, like people are coming to Polynesia, but it looks like Polynesians are going to South America and then back again.
But they actually proved that boat came from Polynesian island to the South America. They made the expedition.
He demonstrated that it's possible. Yes. He definitely demonstrated it's possible, yes.
Right, any other another question here?
The island where you were doing the carbon dating.
Yeah, on Java.
And you had, it was almost miraculous that you actually got there. So I'm assuming there is no one living there now.
No, there are. There's a couple hundred people living on the island. That's the village.
Still.
Yeah, the villages. Those are people living.
But they don't.
They're disconnected from everything, except they have cell towers. It's interesting that Solomon Islands put a cell tower. Yeah. So the funniest thing, they're living in basically very basic existence. Happy people. The sense of poverty from our sense, not the same kind of poverty in the sense they're poor, but they go out and get fish and they get their it's very subsistence, living their life. But Solomon Islands put a cell tower in there, so people. One of the things they do with the money they make from the sea cucumber is they get like cell phones and they watch YouTube. So we're walking along, people are like watching YouTube. It's like this crazy like what? And our phones would ring. It'd be like crank, whatever, a spam phone call. It'd be like we're in the middle of 200 miles offshore and someplace that you can't get to. Yeah, we have this phone call. It was a very bizarre experience. But it was wonderful. It was a wonderful experience.
Were they asking you about your extended car insurance?
Yeah, no, exactly. Oh, we've got a deal for you. Yeah,
we do have a question from the chat. Fred asks, are all the statues dated from the same date or date range? And are they built, installed in the same time and when?
That's a good question. We don't know. One of the things that, if you're interested in archaeology, there's a ton of things to figure out with archaeology. One of which is chronology. We don't really have good evidence. We don't have good data about the chronology. We know that people started making them after they arrived, and we know that they were making them probably when Europeans arrived. But between that, we actually don't really know. And the reason why is because, one, there hasn't been enough. It's very complicated to get excavation to get material that you can then date. But you can't date the statues directly. You have to date carbon material associated with the statue. So you have to find like a piece of charcoal that's underneath the statue that you then date and know that the statue was put there after the carbon was put there. So it's very difficult to date them. And as a result, there hasn't been much dating done. So we actually don't know. It's really sort of, we know it's probably over, we know it's over the period of time that they were there, and we know it stops after Europeans arrive, but then between that, so.
It's interesting though that the song of the statues walking, it continues, it was being passed down from generation to generation, literally centuries.
Yeah.
Why would they do that?
Well, interesting. I mean, one of the things we've thinking about living on a small island with a small population is that you have to worry about knowledge. Like we don't think about it because we write knowledge down, we put it in books, and we have large people where somebody somewhere remembers everything. So and the internet makes that totally possible. Like the internet is your brain that somewhere that knowledge is there. But an island that's living remotely means that each person has some potential chunk of knowledge that you might need and that is connected to that person, and especially older people who have gathered that knowledge. The challenges with small populations is those people die. and you lose that knowledge. So what you do is you encode it in songs, you encode it in stories, and you encode it in even writing systems. So on Rapa Nui, there's actually Rongo Rongo, which is a script that is undecoded, so to speak. And it's likely that the Rongo Rongo script is an encoding mechanism for information, that it's a way of retelling stories over and over again so you can pass them on. Because knowledge on an island like that is really critical. The experience you had 50 years ago under some condition in which the moon came and brought fish to that spot is something that someone needs to remember, so if that ever happens again, you can take advantage of that. Somehow you have to encode that into your system, and with limited population, you have to have oral traditions. So their islands are very good at maintaining oral traditions. Because they're very important.
Okay. You've just touched on what my question or concern is, and that is the oral tradition. There's even biblical archaeologists have found that a lot of the stories which predate writing have solid basis. Maybe not in the details and a lot of stuff that we see, but the basis is very solid for oral tradition, and studies have been done that show that oral tradition is typically very accurate.
Yeah, it's ancient. I mean, because it's sort of that's where the source of us is through these oral traditions that have passed on knowledge until we started writing it down and then now putting it on machines in the cloud. But oral traditions are really key to the survival of most of humankind.
So my question is, has anybody done any real study of the oral traditions, say of...
oh, we do. And the challenge on Rapa Nui, the challenge with oral traditions, we know there are bits and pieces that are telling us something about the past, but any particular oral tradition is a combination of things from the past plus new things that came in, plus the consequences of European arrival, plus it's a big mix. And so you can't really start with the oral traditions. What we can do is look at the archaeological record and say, this is consistent with what we're hearing in the oral traditions. It kind of has to go back to that material record, because the oral traditions will you can find every story of everything, and they're all from different sources, and it's very difficult to parse them apart. But we do know there's knowledge in there, and there's definitely continuity. There's an immense, if you go visit Rapa Nui today, the Rapa Nui people living there, they speak Rapa Nui, which is amazing, because at one point, 1877, there were only 111 people on the island as of the census living on the island. Incredibly small number of population due to the effects of disease and slave raiding that came on in the 19th century. But yet they still maintain their language to today. So it's a remarkably resilient population that are passing this information on.
Well, Dr. Lipo, thank you so much
you're
again
welcome.
for your for this great presentation. So I'll keep watching your
Okay.
Your
We're going to know
website.
in a couple weeks the answer to the date. So
Excellent. All right. Well, we'll definitely have to have you come back. And what we normally do here is, especially for those people who've been here for the first time, you can't leave until you look through a telescope. It was clear. It then clouded up. I don't know if it looked like it was starting to clear up again. So we invite you to come back out. We had Saturn in the 6-inch, right? That's still in there. So, and we also have a what's called an electronically assisted astronomy. It's called a C-STAR, and it's a telescope that actually doesn't. You don't look through it, but what it does is it communicates to a tablet. And so, Bryn, one of our interns, is actually going to be trying to image a nebula, and it'll actually show up on the tablet. So, we invite you to come out there. You also notice that. We've got red in the lobby, so we're trying to keep. We now want you to start using your outside, night vision. So that's why we don't have white lights in the observatory or now in our lobby. So thanks again. Next week, Friday and Saturday is Hocus Pocus. Then the following Friday is just a casual night of observing. So thanks again for coming, and we'll for those of you who are also have just come up here for the first time, on your way home, watch out for the deer. All right, have a good night.